Good morning, students. In the last class, we discussed about what happens when an AC source is connected to the capacitor, right? So this is the capacitor. When we connected this capacitor to the AC source of voltage V is equals to Vm sin omega t, right? So that is V is equals to Vm sin omega t, which is the capacitance of the capacitor, and I is the current which is flowing in the circuit, right? So that I we treated I is equals to Im sine of omega t plus pi by 2, right? So comparing these two, we can state it that current leads the voltage by 90 degree or pi by 2, right? So that is the current which leads the voltage by 90 degree or pi by 2. So that we can represent it as taken I along y axis and voltage along x axis. So the angle between I and V, that is equals to 90 degree, that is pi by 2, right? So the phase angle, we call this one as phase angle. So that phase angle is pi by 2. That means phase is denoted by pi, so pi is equals to pi by 2. So where pi we call that one as phase angle. Phase angle pi, that is equals to pi by 2, right? So this stated the reference taken as voltage. So current leads the voltage by 90 degree. That means current is ahead of the voltage, right? So if we take a current as reference, so if we rotate this one in the anti-clockwise, the clockwise direction, right? So if you rotate this in the clockwise direction, as these two are perpendicular to each other, if I rotate I, again the voltage also rotates by an angle pi by 2, right? So from this we can write this one as I and V. So here also angle pi, that is equals to pi by 2. So this we can state that voltage lags the current by pi by 2, right? So we can use either current leads the voltage by pi by 2, or we can state that as voltage lags the current by pi by 2. So if the current is leading means, so I is perpendicular to V, right? So in the first quadrant, so we taken voltage as reference. So voltage is lags. That means so voltage lags by 90 degree. So voltage ಎಷ್ಟು ಹಿಂದೆ ಇರುತ್ತೆ current ಏನು ಅಂದ್ರೆ by the angle 90 degree, right? So ಇಲ್ಲಿ current voltage ಗಿನ ಮುಂದೆ ಇರುತ್ತೆ. So ಎಷ್ಟು ಮುಂದೆ ಇರುತ್ತೆ pi by 2. So voltage current ಗಿನ ಎಷ್ಟು ಹಿಂದೆ ಇರುತ್ತೆ, that is pi by 2, right? So here the term lag and leads, so these two are very important, right? So current leads the voltage by pi by 2, or voltage lags the current by pi by 2. So ಇದನ್ನ ನಾವು ಎರಡು ಸ್ಟೇಟ್ಮೆಂಟ್ ಅಲ್ಲಿ ಕೂಡ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡ್ಕೊಬಹುದು, right? So next Im. So here we taken Im is equals to C omega Vm, right? So here we get it a constant, so that constant we replaces by the peak current. Im is equals to C omega Vm, and this Im is equals to Vm divided by 1 by omega C. We can write this one as in the form, right? So if we shift this to the numerator, again we get the same value, that is C omega Vm, right? So now comparing this with the relation, Im is equals to Vm divided by R, right? So comparing, so in place of R we have the value, that is 1 divided by omega C. That means 1 divided by omega C acts as a resistance. So here we have the capacitance, we have the capacitor, hence so capacitor having the capacitive reactance. So that means this is also the resistance, right? So we write this one as V is equals to 1 divided by omega C, right? So Xc we call that one as capacitive reactance. when X is the capacitive reactance and that capacitive reactance is equals to, that is Xc, we know omega is equals to 1 divided by 2 pi f, right? So omega is equals to 2 pi f into C. So capacitive reactance Xc, that is equals to 1 divided by 2f into C. So here 2 is constant, pi is constant and C is also the constant, hence the capacitive reactance Xc is proportional, inversely proportional to the frequency of the current. So S to frequency is nothing but the number of conversions from positive value to negative value in 1 second, so that we call that one as the frequency, right? So this is one important relation. So Xc is inversely proportional to the frequency of the applied current or applied voltage, right? So if we write the relation for Xc versus frequency, if we write the graph for the frequency and for the capacitive reactance, so we get the curve like this, right? So exponentially decreasing curve, right? So this is the curve for the relation Xc and frequency, right? So important relation is when Xc is equals to 1 divided by omega c, or Xc is equals to 1 divided by 2fc, where omega is the angular frequency, so that omega is equals to 2 pi f, or omega is equals to 2 pi divided by d, right? So this is about the capacitive reactance. So this capacitive reactance acts as a resistance. So this capacitive reactance acts as a resistance and its units is equals to same as the resistance, and that is ohm. Its unit is same as that of the resistance and the unit is ohm, right? So now right, so power in instantaneous power. So power we are calculating at any particular time, so that power we call as the instantaneous power, right? So power, we know the relation P is equals to I square R, but here we don't have any resistance in the circuit. We having only the capacitor and that of the voltage, that is AC source, right? So we can write this in the another form, P is equals to I into V, right? Or here we take on small I. So we can write I square R I into V. So here we are going to find the instantaneous power. So we have the value for the instantaneous voltage and instantaneous current, right? So substituting here P is equals to I, we can write that one as I am sine omega t plus pi by 2. So this is what the instantaneous current. Next, voltage. So instantaneous voltage is Vm sine omega t, right? So multiplying these two terms, Im Vm sine omega t plus pi by 2, we can write this one as cos omega t into sine omega t, right? So sine of 90 plus theta, we can write that one as cos theta. So sine of 90 plus omega t, we write that one as cos omega t, right? So multiplying and dividing this equation by 2, right? So that is Im Vm divided by 2 into 2 cos omega t sin omega t, right? So this is in the form of 2 sin x cos x or 2 sin x cos x. So that we can write as Im Vm divided by sine 2 omega t. So sine 2 theta is equals to 2 sine theta into cos theta. So in place of theta we having the omega t. So sine 2 omega t, right? So this gives what? The instantaneous power in a capacitor. So instantaneous power at any particular instant of time, if you want to find the power, so then this gives the relation for the instantaneous power, right? So along with the instantaneous power, one more we have that one as the average power. Average power for a complete cycle. Average power in a complete one cycle. So one cycle is nothing but one waveform. So iduna navenanta karithivi one complete cycle. So if we written this in the form of angles, so that is from 0 to 2 pi or 0 to t. Right? So one complete cycle na now time period anta karithivi, so that we taken as t. Right? So average power is denoted by p bar, that is equals to in the angled brackets I into V, right? So P bar that is equals to, so in place of I into V, we have the term Im Vm divided by 2 sine 2 omega t, right? So these two terms are constant, so we can take outside Im Vm divided by 2 within the angled brackets. We need to find the average value of sine 2 omega t, right? So we need to find the average value of this term. So in the last, by solving the resistor, then we calculated the average power, right? So any function, if you want to find any function's average value, then that value is equals to 1 by t. So the limit 0 to t, f of t into dt or f of x into dx, right? So if we integrate this value, we get the average value of the function. So here we have the function sine 2 omega t, right? So we write this one in the angle bracket. Sine 2 omega t, that is equals to 1 by t, 0 to t. So over for one complete cycle, so we are calculating the average power for one complete cycle, that is starts from 0 and ends at t. So that's why we take the limit from 0 to t. So in place of f of t, we having sine 2 sine 2 omega t dt, right? So if we integrate this value 1 by t, so integration of sine 2 omega t, we getting minus cos 2 omega t divided by 2 omega. So its limits from 0 to t, right? So now differentiate ಮಾಡಿದ್ರೆ cos 2 omega t differentiate ಮಾಡಿದ್ರೆ ನಮಗೆ sin minus sin 2 omega t, because here we don't have any minus, hence we taken minus here itself, right? So minus cos 2 omega t. So if we differentiate cos 2 omega t, sin 2 omega t into 2 omega, so minus into minus plus, and 2 omega get cancel, again we getting the same value sin 2 omega t, right? So here 2 omega and minus are constant, so taken outside minus 1 divided by 2 omega t. So substituting the limit cos 2 omega capital T minus cos 0, right? So 1 divided by minus 1 divided by 2 omega t. So cos 2 into 2 pi t into t minus cos 0 value is 1, right? So t get cancelled. Cos 2 into 2 pi, that is cos 4 pi. Cos 4 pi is nothing but cos 0. So this value is also equals to 1, right? So 1 minus 1 is 0, right? So 0 into anything is 0, right? So the average value of sin omega 2 omega t is 0. So substituting here, Im Vm divided by 2 into 0. So average power is equals to 0 in case of the capacitor, right? So now this is for the explanation purpose to find the average value of sin 2 omega t. So sin 2 omega t average value ಯಾವಾಗಲೂ ನಮಗೆ ಎಷ್ಟಿರುತ್ತೆ 0 ಇರುತ್ತೆ, right? So 0 into anything we getting the 0. right? So average power in the capacitor for a complete one cycle, so average power is 0. But the instantaneous power, that means if we want to find the instantaneous power at any particular time, so here it is some pi by 2, right? So just substituting here, right? So if we substitute here, we get the power value, right? So that is what the instantaneous power at any particular time in between one cycle. So that value is what? That is the instantaneous power, right? So this is about the instantaneous power and average power in case of the capacitor, right? So important one is the graph which relates with the capacitive reactance and to that of the frequency, right? So next is when an AC source is connected to an inductor. So in the last class itself I mentioned. So what is inductor? So inductor is nothing but a coil. So ಯಾವುದಾದ್ರು ಒಂದು ವೈರ್ ನ ತಗೊಂಡು ಅದನ್ನ ಬೈಂಡ್ ಮಾಡಿದ್ರೆ ನಮಗೆ ಏನು ಸಿಗುತ್ತೆ? ಕಾಯಿಲ್ ಸಿಗುತ್ತೆ. So that coil we call as inductor, right? So what happens when an inductor? So this is the symbol of the inductor. So spring shape ಅಲ್ಲಿ ಇದನ್ನ represent ಮಾಡ್ಕೊಳ್ತೀವಿ. We call this one as also the coil. So inductors having the inductance L which is connected to the AC source. So the voltage across the AC source is V is equals to Vm sin omega t. So here we consider the pure inductor. That means the resistance in the coil is 0. But the complete resistance will not always be equals to the 0. So only some part of the resistance will be present in the inductor, right? So inductor is also nothing but the conductor, right? So here we are going to find the current which is flowing in the inductor. So what happens when the current which is flowing in the inductor, right? So the source voltage we apply V is equals to Vm sin omega t, where V is the instantaneous voltage across the inductor and Vm is the peak voltage, that means the maximum voltage, right? So applying the Kirchhoff law for the inductor, right? So here it produces the EMF. So inductor in ಮಾಡುತ್ತೆ, it produces the EMF. That EMF of the inductor we taken E is equals to minus L into di divided by dt, right? So ಯಾವುದಾದ್ರು ಒಂದು inductor ನ either AC or DC source ಗೆ connect ಮಾಡಿದ್ರೆ it produces the EMF, right? So that EMF value is always equals to minus L into di by dt, where di by dt is the rate of change of current, right? So ಇದನ್ನ ನಾವು ಇಂಡಕ್ಟೆನ್ಸ್ ಸ್ಟಡಿ ಮಾಡಬೇಕಾದ್ರೆ ಡೀಟೇಲ್ ಆಗಿ ಸ್ಟಡಿ ಮಾಡ್ತೀವಿ. So just now here we need the voltage across the inductor, right? So voltage across the inductor E is equals to minus L di by dt. So this minus we taken, that is from the Lenz's law, right? So now applying Kirchhoff rule or law. So if we apply the Kirchhoff law, here we have the voltage and also the EMF which is produced across the inductor. We have the value is equals to minus L di by dt. So that shows that here we don't have any resistance. So hence the IR product is 0 in this case, right? So algebraic sum of IR product is equals to the sum of the EMFs or voltages which are present in the circuit. So here we have the two voltages, right? So IR product is 0, that is equals to sum of the two voltages, right? So one is V and plus another one is E, right? So voltage we have Vm sin omega t, and E we having minus L di by dt, that is equals to 0. So 0 is what? Higher product. Here in this circuit only inductive, so here there is no resistance, so hence I into R value is 0, right? So replacing Vm sin omega t, that is equals to L into di by dt. So here we are going to find the current which is flowing across the inductor. That means we need I. So write di, that is equals to Vm divided by L. So it goes to the LHS, it becomes Vm divided by L sin omega t into dt. Right? So where di means small current which is flowing in the circuit. So we are going to find the total current I. So small current होता है, then हमके total current बेकंद्रे we are going to integrate this equation. So if we integrate this equation, we get the total current I which is flowing in the circuit, right? So integrate this equation, integration of di, that is equals to integration Vm divided by L sin omega t dt, right? So integration of di, we getting the total current I. Vm is constant and L is constant, so we taken Vm divided by L outside. Now integration of sin omega t into dt. So integration of sin omega t, we getting minus cos omega t divided by omega, right? So along with this, we are getting one constant. So this constant we call as the integration constant. So idu ನೀವು integration study ಮಾಡಬೇಕಾದ್ರೆ ಇದ್ರ ಕಾನ್ಸೆಪ್ಟ್ ಬಗ್ಗೆ ನಿಮಗೆ ಐಡಿಯಾ ಇರುತ್ತೆ, right? So maths ಅಲ್ಲಿ ಬರುತ್ತೆ. So this we call as the indefinite integral. So we get this equation. So differentiation of a constant, we get the value is 0. So hence here we don't have any value. So here we don't have any value means that value is 0. Hence if we integrate the 0, we getting a value. So that value is the constant, right? So ಅದು ನಿಮಗೆ ಇಂಟಿಗ್ರೇಷನ್ ಅಲ್ಲಿ ಕ್ಲಿಯರ್ ಆಗಿ ಅರ್ಥ ಆಗುತ್ತೆ, right? So now this constant is the constant value relates with the current. So this constant ಯಾವುದು ಇರುತ್ತೆ ಅಂದ್ರೆ this is relates with the current and it is independent of time because this value don't have any t. Hence this constant is independent of time and it relates with the current, right? So as the current is varying in between, that is voltage is varying from higher value to lower value through the zero. So same as current is also varying from higher value to lower value across the zero value. So hence this constant we taken as 0, right? So this constant we taken as 0. So we getting I is equals to Vm, that is minus Vm divided by omega L cos omega t, right? So now we can write this I, that is equals to Vm divided by omega L sin of omega t minus pi by 2, right? So sin of 90 minus theta, we getting cos theta again from the trigonometric function. So sin of minus theta, so we getting minus sin theta, right? So minus Vm by omega L into cos theta, we can write that one as Vm by omega L into sin of omega t minus pi by 2. So ಇಲ್ಲಿ ನಮಗೆ pi by 2 minus omega t ಬರ್ಕೊಂತೀವಿ. So minus ಕಾಮನ್ ತೆಗೆದ್ರೆ minus ಹೊರಗಡೆ ಬರುತ್ತೆ. Again pi by 2 minus omega t, we getting cos omega t, right? So this we can replace with the constant I is equals to Im sin of omega t minus pi by 2. So this is the current which is flowing in an inductive circuit, right? So where Im is equals to Vm divided by omega L, right? So comparing this with Im is equals to Vm divided by R, right? So in the place of Im we are having Im, in the place of Vm we are having Vm. So in place of R we are getting omega L, where R is the resistance and omega is the angular frequency and L is the inductance of the coil or inductance of the inductor. So this omega L acts as a resistance in the circuit, right? So hence we can write that one as replacing XL, that is equals to omega L. So this XL we call that one as inductive reactance, right? So R ನ resistance ಅಂತ ಯಾವ ತರ ಕರೀತೀವೋ XL ನ ನಾವೇನಂತ ಕರೀತೀವಿ inductive reactance, and the you call that one as the inductive reactance, and hence here also the unit is same, so that is ohm. So resistance के एक unit ಇರುತ್ತೋ inductive reactance को ಕೂಡ same unit ಇರುತ್ತೆ, that is ohm. So simply we say XL, inductive reactance, is nothing but the resistance which is acting in the inductive circuit, right? So again omega we know, so omega is equals to 2 pi f, then XL is equals to 2 pi f L, right? So here 2 is constant, pi is constant, and L is constant. So inductance L, which depends on the material of the coil, right? So hence now ಯಾವ್ದಾದ್ರು ಒಂದು material ತಗೊಂಡ್ರೆ ಅದ್ರದ್ದು inductance ಏನಿರುತ್ತೆ remains constant ಇರುತ್ತೆ. Hence XL is directly proportional to the frequency, right? So if frequency of the current increase ಆದ್ರೆ XL value ಕೂಡ ಏನಾಗುತ್ತೆ increase ಆಗುತ್ತೆ, right? So if you plot the graph for XL versus frequency, so we get in the linear line, right? So f value increase ಆಗ್ತಾ ಇದ್ರೆ XL value ಕೂಡ ಏನಾಗ್ತಾ ಹೋಗುತ್ತೆ increase ಆಗುತ್ತೆ, that is because of it directly relates. So if f value is 10, XL value is 10. If f value is 20, XL value is 20. So if we plot the graph by using those values, we get the straight line that is also passing from the origin, right? So this is about the relation which between the inductive reactance and to that of the frequency. In case of capacitor, we have the relation XC is inversely proportional to frequency, but in case of the inductor, we have XL that is proportional to the frequency F, right? So now we are going to study how the voltage and current varies, right? So here we have the relation V is equals to Vm sin omega t, and also I is equals to Im sin of omega t minus pi by 2, right? So here where I is the instantaneous current and that value is I sin of omega t minus pi by 2, right? So by plotting the graphs, right? So V, and here it is omega t. Omega t, here we have I, right? So taken 0 for one complete cycle, 0, pi by 2, pi, 3 pi by 2, and 2 pi. So 360 degree, right? So taken here. This is 0, right? So again by varying the values here omega t, right? So because we have taken omega t values as pi by 2, pi, 3 pi by 2, and 2 pi. In the first case when omega t is 0, so what happens for voltage and what happens to the instantaneous current and instantaneous voltage, right? So in this case when omega t is 0, so sin 0 is 0, so 0 into m is 0, and we get v is 0. Here we get in the first point voltage, right? So next in the same case when omega t is 0, right? So this is 0, so 0 minus pi by 2 is minus theta is minus sin theta, that means minus Im sin pi by 2. So sin pi by 2 is 1 into Im is Im, that is minus Im, right? So we getting the value in the negative axis. When omega t is equals to 0, we getting the value is minus Im. So here the value is minus Im. So here we have voltage is 0, but current is in the negative. That is minimum value, right? So next case, I'll write here, Im is equals to minus I is equals to minus Im, right? So next, when omega t is equals to pi by 2, right? So that means sin 90, 1 into Vm is Vm. Vm is what? The peak value. So somewhere here I will take Vm, that is peak value. So I will plot here, right? So this is what? The peak value of the voltage. So same wise here, omega t is pi by 2. When omega t is pi by 2 minus pi by 2 is 0. 0 into Im is 0. So we get, when pi by 2, we get the current I is 0, right? So next, I, that is equals to 0. Next, when omega t is pi, that is infinity, that is equals to 0. So 0 into Vm is 0. So we get instantaneous voltage V is equals to 0 when omega t is pi, right? So same wise here it is pi minus pi by 2. So 2 pi minus pi by 2, that is pi by 2. So sin 90 is 1 into Im is Im. So we getting the value I is equals to Im. So here the Im is positive value. So somewhere here I will take the Im value. So when it is pi, we getting the maximum current here, right? Next, when omega t is equals to 3 pi by 2, that means 270 degree. When sin 270 is minus 1, so minus 1 into Vm, we getting the minus value, right? So that is minus Vm. Here somewhere here I will take the value as minus Vm. So that is negative voltage. So same wise 3 pi by 2. So here 3 pi by 2 minus pi by 2, 2 pi by 2. 2 get cancelled. So sin pi is 180. 180 means 0. 0 into Im is 0, right? So we getting the value here 3 pi by 2. The value is 0, right? So I value is equals to 0. And the last one is when omega t is equals to 2 pi. 2 pi is 360 degree, that is equals to 0 degree. So sin 0, 0, that is 0 into Vm is 0. We get voltage is 0. So in the same case, omega t is equals to 2 pi. 2 pi minus pi by 2, that is 4 pi minus pi by 2, 3 pi by 2. 3 pi by 2 is 270. So sin 270 is minus 1 into Im is minus Im. Again we get I value is minus Im, right? So somewhere here we get the value, right? So this is the graphical represent. Now joining all these dots, we get the voltage curve, that is sine curve, right? So in the same way, if you join the points, so it starts from negative, then to positive, again to negative, and it continues, right? So now observing this, so I will write here both I and B. If I write combined together, so we'll get the curve. So E curve ne will represent modifying. So black line represents what? Instantaneous voltage, and the red line represents the instantaneous current, right? So if you observe here, when the voltage reaches maximum, the current reaches minimum. That means 0. So first voltage maximum ಹೋಗ್ತಿದೆ ಅಂದ್ರೆ current ಏನಾಗುತ್ತೆ ನಮಗೆ minimum ಇರುತ್ತೆ. So ಈ ಕೇಸ್ ಅಲ್ಲಿ ತಗೊಂಡ್ರೆ when the voltage is 0, the current is minimum. That means it is in the negative value, right? So the first voltage reaches the 0 value, then the current reaches the 0 value. That means voltage first 0 ಬಂದ್ರೆ ಆಮೇಲೆ current ಏನಾಗ್ತಿದೆ 0 ಬರ್ತಿದೆ. That means voltage is ahead of the current, right? So voltage ಮುಂದೆ ಇದೆ, current ಏನಿದೆ ನಮಗೆ ಹಿಂದೆ ಇದೆ. voltage ಹೋದ್ಮೇಲೆ ಏನು ಬರ್ತಿದೆ ನಮಗೆ current move ಆಗ್ತಾ ಇದೆ, right? So that is by the angle is pi by 2. So in each case ಅಲ್ಲಿ compare ಮಾಡಬಹುದು, right? So first voltage 0 ಬಂದ್ಮೇಲೆ current 0 ಬರೋದಕ್ಕೆ time ಎಷ್ಟು ತಗೊಳುತ್ತೆ pi by 2, right? So in the same case voltage 0 ಬಂದಾಗ next current 0 ಬರಬೇಕು ಅಂದ್ರೆ time ಎಷ್ಟು ತಗೊಳುತ್ತೆ again pi by 2. 3 pi by 2 minus pi, we getting the pi by 2, right? So that means from this we can state that current lags the voltage by 90 degree or pi by 2. This is in the case of inductor. That means lags means ಹಿಂದೆ ಉಳಿಯೋದು current ಹಿಂದೆ ಇರುತ್ತೆ voltage ಮುಂದೆ ಇರುತ್ತೆ or we can say that voltage is ahead of the current. That means voltage leads the current by the angle 90 degree. So ಎರಡು ತರನು ನಾವು ಸ್ಟೇಟ್ ಮಾಡಬಹುದು, right? So here we taken voltage as reference. So if we write the phasor diagram, so along horizontal we can take V and I, which is taken along vertical, that is negative axis, right? So from this we can say current lags the voltage by 90 degree. So first voltage ಬರುತ್ತೆ ಆಮೇಲೆ current ಬರುತ್ತೆ. So here voltage is positive value and current is negative value, right? So that means phase angle or phase difference between voltage and current is 90 degree. So phase difference, that means pi value is always equals to pi value, right? So pi na navenanta karitive phase difference. So phase difference is nothing but the angle which we are measuring. So e difference na navenanta karitive phase difference, right? So illi pi ide, illi pi by 2 ide. So this difference we call that one as phase difference, right? So the phase difference between the voltage and to the current is pi, and that value varies, that is equals to pi by 2, right? So idu ನೀವು first year ಅಲ್ಲಿ ಸ್ಟಡಿ ಮಾಡಿದ್ದೀರಾ phase angle phase difference ಎಲ್ಲದನ್ನು, right? So phase difference is pi by 2, right? So we can also state so no problem solve ಮಾಡಬೇಕಾದ್ರೆ ಇದು ತುಂಬಾ ಇಂಪಾರ್ಟೆಂಟ್ ಕೇಸ್. Also we can state voltage leads the current by pi by 2. That means here along x-axis we taken current and V is the voltage, so that is pi by 2. So this is in case of inductor. So there is a difference in case of capacitor and in case of inductor, right? So in case of inductor voltage leads the current, but in case of capacitor current leads the voltage, right? So ಯಾವ್ದಾದ್ರು ಒಂದನ್ನ ನೀವು ರೆಫರೆನ್ಸ್ ಆಗಿ ಇಟ್ಕೊಂಡು ಸ್ಟಡಿ ಮಾಡಿ, right? Either current or either voltage, right? So ಎರಡಕ್ಕೂ ಕನ್ಫ್ಯೂಸ್ ಆಗಬಾರ್ದು, ಎರಡು ಕೂಡ ನಾವು ಸೇಮ್ ಸ್ಟೇಟ್ಮೆಂಟ್ ಹೇಳ್ಕೊತೀವಿ, ಬಟ್ ಮ್ಯಾಟರ್ ಏನ್ ಚೇಂಜ್ ಆಗುತ್ತೆ ಅಂದ್ರೆ voltage leads the current by pi by 2 in case of inductor and current leads the voltage by pi by 2 in case of capacitor. So ಎರಡು ಸ್ಟೇಟ್ಮೆಂಟ್ ಕೂಡ ನಾವು ಚೇಂಜ್ ಮಾಡ್ಕೊಬಹುದು, right? So this is the phasor diagram. So ಇದನ್ನ rotate ಮಾಡಿದ್ರೆ current ನ rotate ಮಾಡಿದ್ರೆ voltage ಕೂಡ rotate ಆಗುತ್ತೆ with an angle. So ಎಷ್ಟು angle ಅಲ್ಲಿ ನಾವು current rotate ಮಾಡ್ತೀವೋ in the same wise the voltage also rotates. So same the current and voltage remains constant, that is the phase difference always equals to pi by 2. So ಇದನ್ನ rotate ಮಾಡಿದ್ರೆ V ಕೂಡ rotate ಆಗುತ್ತೆ in the same angle, but this angle will not change, right? So 2 marks ಗೆ ಅಥವಾ 1 marks ಗೆ ತುಂಬಾ important, right? So write the phasor diagrams for the inductor which is connected to the AC or capacitor which is connected to the AC, right? So and the last one is instantaneous power. So instantaneous power when the inductor is connected to the AC source, right? So instantaneous power, again here there is no resistance, so hence we can write instantaneous power P is equals to I into V, where I is the instantaneous current and V is the instantaneous value of voltage. So here we know the two values, so substituting here we get P is equals to Im sin of omega t minus pi by 2 Vm sin omega minus Im Vm by 2 cos omega t sin omega, right? So instantaneous power is equals to minus Im Vm by 2 sin 2 omega t, right? So we can find the instantaneous power at any time intervals, pi by 2, pi, 3 pi by 2, 2 pi, right? So any angles we can find the instantaneous power at a particular instant of time. So that gives what? Negative value. So minus Im Vm by 2 sine 2 omega t, right? And the last is average power in an inductor. Average power, right? So here we are going to find the average power. Again, average power is P bar, that is equals to in the angled brackets I into V, right? So we get the value of I into V, that is minus Im Vm divided by 2 sine 2 omega. So minus Im Vm by 2 is constant, so we can take outside minus Im Vm by 2 within the angled bracket sine 2 omega t, right? So in the last case also we find the value of average value of sine 2 omega t. So there we get the value of the average value is 0, right? So here also we have the average value of sine 2 omega t, that value is 0. So P bar is equals to minus Im Vm by 2 into 0. So P bar is equals to 0. That is because, so ಇದನ್ನ ಮತ್ತೆ ಡಿರೈವ್ ಮಾಡೋ ನೆಸೆಸಿಟಿ ಇಲ್ಲ, ಲಾಸ್ಟ್ derive now, right? So that means there will be no average power for one complete cycle in case of capacitor and also in case of inductor, right? So average power is 0 in case of inductor and also in case of the capacitor. So into the derivation and necessity is of sin 2 omega t, that is equals to 0, right? So ನಮಗೆ ಮುಂಚೆ ಎಲ್ಲ ಈ ಥಿಯರಿ ಮೇಲೆ 5 marks ಗೆ ಕೇಳ್ತಾ ಇದ್ರು ಅಥವಾ 3 marks ಗೆ, but they stopped asking the derivations on this concept, right? So next class we are going to study all these three combinations when connected to the AC. That means resistors, conductor and inductor which are connected in series, right? So our derivation is super important, right? We will discuss in our next class. Thank you.